Okay, for today's bell work, we're in the first lesson of Unit 3. The bottom of a snowboarding halfpipe is 5 meters below the top. Circle the integers you would use to represent the situation. If it is 5 meters below the top, how would we represent that as an integer?
Oh, if it were an integer, it would be -5.
-5 because it's below the top. The second part of the bell work wants to describe a situation that uses a negative integer. So what would be an example of when you would use a negative integer? Yeah, what about money? Yeah, if you owe the bank money or if you spent $10, how would we write that? -10.
Why?
If you withdraw or take out money from your bank account, if you withdraw $50, that would be -50. If you think of football, if you have like let's say 7 yards lost, how would you represent that?
-7.
-7. So you can have any situation as long as it represents a negative integer.
Oh.
Okay, so today we are talking about integers and absolute value. Our targets for today are students will be able to read and write integers and find the absolute value of an integer. Alright, for today's notes, numbers like 5 and -8 are called integers. An integer is a whole number that can be positive, negative, or 0. And that is because 0 is neither negative or positive. So any positive or negative whole number is an integer. An example of positive integers would be on the right side of 0 or these numbers over here. 1, 2, 3, 4, 5. And then we have 0 in the middle. It is also an integer. It is just not negative or positive. And then on the left-hand side, we have our negative numbers. -1, -2, -3, -4, -5. The further you get away from 0 is the bigger your negative number. It's a smaller number. So the bigger the negative, the smaller the number. Okay, our next vocabulary word. The blank of a number is the distance between the number and 0 on a number line. What are we going to fill in here?
Absolute value.
Absolute value.
Always the answer to.
Okay, so the absolute value of a number is its distance away from 0. Distance is never negative, so your absolute value is always positive. The first example they give us is -5. -5 is 1, 2, 3, 4, 5 units away from 0. So absolute value is noted by these bars, and you're finding the absolute value of -5, which we know is 5. Same with +5. When you find the absolute value of +5, it is 1, 2, 3, 4, 5 units away from 0, so the absolute value of 5 is also 5. We want to write an integer for each situation. The first one is an average rainfall of 5 inches above normal. Would that be a +5 or a -5? +5. You can write +5 with the plus sign in front or just as 5. If there's no sign out in front, we know that the number is positive. For the second one, if we have an average temperature of 5 degrees below normal, how would we represent that? -5. The next question, they want us to evaluate. What is another word for evaluate?
Look at. Solve.
Solved. So we're going to solve the expression. Remember, these bars are mean absolute value. What is our absolute value of 5? Or how far away is it from 0? 5. It's 5 units away. I'm going to bring down my minus sign. What would be the absolute value of 2? 2. And 5 minus 2 gives me a value of 3. If we go over this, we are writing an integer for each situation. 6 degrees above normal, would that be a positive or negative 6? Positive 6. You can write it as 6, or if you want, you can put the plus sign in front of it. For our next one, 2 inches below normal would give us negative 2. Okay? When you are graphing a set of integers on a number line, so we want to graph these numbers. This is our group of numbers. They're inside brackets. We want to find each one of these on the number line and graph them. So for negative 4, I'm looking for negative 4 on my number line, and I'm going to graph that on the number line. Then I have my next number, which is 1. I'm going to go to 1 on the number line and graph that value on the number line. After that, we have negative 3. I go over to negative 3 and graph that on my number line. And my last value is what? 2. Positive 2. And I graph that on my number line. When we're evaluating, we know that evaluate means solve. I want to look at my numbers inside my absolute value bars. What is the absolute value of negative 6? 6, and I'm going to bring down my minus sign. What is the absolute value of 5? 5. What is 6 minus 5? 1. There's my answer. For the next one, what is the absolute value of 2? 2. And what's the absolute value of 3? Or negative 3? 3. Bring down my plus sign. 2 plus 3 gives me 5. So when you evaluate the expression, you evaluate inside your absolute value bars before you add or subtract. The last question I want you guys to try on your own. Why is the absolute value of a non-zero number always positive? And explain. So I'll give you guys about a minute on that one before we go over it. Anything along the lines of absolute value is the distance away from 0, and distance cannot be negative.
That was a line.